To find the tangent to a curve y equals f of x at a point P, A, and f of A, calculate the slope of the secant line through point P and a point Q, which is A plus H, f of A plus H. Anyways, very close to each other. Next, investigate the limit of the slope as H approaches 0. If the limit exists, it is the slope of the curve at P, and we define the tangent at P to be the line through P with this slope. Okay, maybe a picture will help you guys out. If you go through and we have a curve and we have our line, our secant line, and what we're trying to do is we're trying to get it tangent here, is that we would bring these values closer and closer and closer together until it got down here. And that's where they're using the A plus H, but we put our values much, much closer together. So the slope of the curve y equals f of x at the point P being the point, A, f of A, is the number, the limit as h approaches 0 of f of A plus H minus f of A all over H. By the way, your A value is whatever number they give you for the value of x. And what we're doing, instead of actually coming up with another number like we did earlier, 2 and then 2.001, we're going to just do the limit as h gets closer and closer to 0 to get our limit, and that's going to be our slope. And this is provided the limit exists. The tangent line to the curve y equal to the curve at P is a line through P with this slope. Okay, let me get rid of. It was just driving me crazy. Okay. So here's one thing to keep in mind. They can use any of these words when they're asking you to do something. All of the following mean the same thing: slope. The slope of y equals f of x at x equals a. The slope of the tangent to y equals f of x at x equals a. The instantaneous rate of change of f of x with respect to x at x equals a. The limit as h approaches 0 of f of a plus h minus f of a all over h. And then you've seen this one as pre-calc. F of a plus h minus f of a over h is just the difference quotient. And we learned that in one of the sections of pre-calc last year. Okay, the normal to the curve, the normal line to a curve at a point is the line perpendicular to the tangent at the point. The slope of the normal line is a negative reciprocal of the slope of the tangent line. Something you guys already knew. So now we already did this problem before, and we even found a slope value of -2, but I want to use the difference quotient to verify what we got. So we're going to do the limit as h approaches 0 of f of -1 plus h minus f of -1 all over h. So this is going to give us -1 plus h squared plus 2 minus minus -1 squared plus 2 all over h. So the limit as h approaches 0 of this, and hopefully you guys remember this from last year, that this is a perfect square used binomial expansion. We'll talk about it more in class. But we're going to get h squared plus 2h, actually I lied, it's minus 2h, minus 2h plus 1 minus, and in parentheses, 1 plus 2. Oh, I forgot the plus 2. Let me erase. I did what was in parentheses, but I forgot that plus 2. Plus 2 minus -1 squared is just 1 plus 2 all over h. Now combine your like terms, so you have h squared minus 2h plus 2 I'm working, my brain is not working. Okay, try that again. I was looking at the 2, forgot the 1. Plus 3 minus 3 all over h. So continue cleaning this up. I get the limit as h approaches 0 of h squared minus 2h all over h. The 3's would cancel out. And at this point, anything that doesn't have an h should cancel out. Because now I can factor out the h, so I get h times h minus 2 over h, and these cancel out. So now I can calculate the limit as h approaches 0 of h minus 2 over h, and that is going to give me negative 2. Oh, actually I lost that h. It's going to give me negative 2. So we verified the slope that we got earlier, even though earlier we had to kind of guess. We had to kind of play with it. And now let me recall that when x equals negative 1, my y value is 3. And I have a slope of negative 2, but they asked us for normal, which is perpendicular. So the perpendicular slope is 1/2. So my equation of my line, y minus 3 equals 1/2 times x minus a negative 1. And I have here the equation. You guys saw this equation earlier, this one here, and then there's my tangent line, and there is my normal line. Notice the slopes are exactly the same. If I put the half through, this becomes 1/2. If I add 3 to that, I get 3.5 or 7/2. So we can even double check our line. Okay, do make sure you know the difference between tangent and normal. Okay, we have one more. I don't have the graph on here. Don't know why. It's not there. So in this one here, before we got a slope of 4. So we just want to verify it. So again, we're going to do the limit as h approaches 0 of 2 plus h squared minus 2 squared all over h. Remember, it's f of a plus h minus f of a. So this gives us h squared. I don't need the parentheses. This gives us h squared plus 4h plus 4 minus 2 squared, which is 4, all over h. My 4's cancel out, so I'm left with h times h plus 4 all over h, and my h's cancel out. And so when I do the limit, as h approaches 0 of h plus 4, I get 4, which is what we got before. Granted, we got 4.001, but we got 4. So I have x equals 2, y is going to be 4, 2 squared. My slope equals 4, but we want the normal line. So the perpendicular slope is negative 1/4. So y minus 4 equals negative 1/4 times x minus 2. And there is our perpendicular line to the tangent line that we did earlier. So one little last bit here, speed revisited. We played with speed, doing instantaneous speed, average speed. The function y equals 16t squared is an object's position function. This is something to remember. An object's average speed along a coordinate axis for a given period of time is the average rate of change of its position. Its instantaneous speed at any time t is the instantaneous rate of change. a position with respect to time at time t, or whatever that time is. So t is just taking the place of a. It's t plus h minus f of t all over h, and you do the limit. As we get into chapter 3, we'll get away from doing limits and more into derivatives and get to our answers much quicker. All right, well, this is the end of chapter 4. Good luck on all of the assignment, and I hope you guys do well.